Okay, we should be live soon. I'm just trying to configure this live request tool. Hmm. Hmm. You don't know. Sorry. We. 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 Okay. Hmm. Not really working. Okay, never mind. Let's go. I don't know, it says unstable connection, but okay. looks fine. Hmm. Okay. So next question, permutations. Given a collection of distinct integers, return all possible permutations. Hmm. Okay, so I think we can actually uh use for loop backtracking in this. But okay, let's think about it for a second. So we start with every index and find all combinations starting from that index. Now we do not need that item in our array anymore, so we remove it. Okay, so let's just write a helper function. Now what all is it going to have? It's going to have a vector int list passed to it, which will be our return value, of course. It'll have the nums array, and I don't know what else we'll need. So let's just start with this helper uh, vector vector int ret vector int. Now our conditions. So okay, our now we'll also of course need our current set that we've made. Let's call it path. This will be a vector int. So if path dot size is equal to let's also send what is our target size, which is nums dot size. So we are also taking in another vector int, which is the path, and a number which is our target length. So if our path is of our target length, we add that to our return value and return. If else, if our nums array is empty, then we can't do anything. Let's just exit. Okay, that's it. Then for I equals 0, I is less than nums dot size. I plus plus. And we shall be calling helper again. So first we add the ith element to our path dot pushback nums I. We also modify nums and erase the ith element. Now send ret nums the new made path and the target. Then we the last element that is in our path, and no, beginning back, and we path pop back, pop, and also nums dot insert at I last. I think that's it. No matching function to call eraser. I mean, sorry, erase C++. Erase is iterator. Plus I. Okay. No matching function call for this. No problem. We have insert right here. I'm blind. So it's iterator position and then the value. So it's nums dot begin plus I. Cool. Perfect. Might fail a case where nums is empty. Maybe. No, it didn't. Great. So this is pretty obvious. Now, given a collection of numbers that might contain duplicates, return all possible unique combinations. Unique combinations. Okay. Now we already did a unique combinations question. Maybe we can take a hint from that. Let's say we sort our input. And if for a path this element is not the start and is equal to the previous element, then just return. Right. So let's just take this code because writing it is sort of tedious. Let's place the name of the function. Okay. Now the only case that we have to watch is if so there was a beginning variable, right? So this always begins at 0, but we don't have really want it to begin at 0, do we? Because it would be 1 1 1 and then oh sorry 1 2 2. So we already have 1 and 2 in the list, Uh, hmm. Maybe we can't straightforward use that logic, of course. Otherwise, why would they put this question here? Um, Basically, our case, we picked 2, then this is the remaining array. So we picked 1, then we picked this one. But if we already picked 2, and we're picking something, um, and we're picking something, we're picking this, then if it's already been picked, how do we know if it's already been picked? Maybe we can keep a map. That tells us if, like, what number has been picked for what position. So if that number has already been picked for that position, so if that path already exists, basically, if that is the subset of any other path, then we quit. That's what I'm thinking. Now I am not able to put a finger on that if. Sorted. Or they're just they're actually using just that, but they're saving this other number also, right? Oh, okay. It's not saving anything. Hmm. So if I equals 0, sorry, if I equals 0 and I equals 0, his case was that the which two numbers are not same? The which two numbers are not same when, okay, so he's saying if I is not equal to 0 and nums I is equal to nums 0, return. So that means that if you're just starting, then ignore, and um sorry, continue. And if we find uh, if our array the first element in our array we want the last swapped index only. So we need a beginning as well, because we don't want to delete then. Fine, we can keep a variable that we use as a starting index for each iteration. if we don't remove our items. So I think this is also something I have learned just now, that um, you can actually how you can actually use the same array without removing elements from it is by swapping those two. They are pushing it, right? Oh, they're actually pushing num itself, but they're swapping here. When are they swapping in back? Oh, never. So for each, what? Okay. If we do not recover the numbers, then the code will prevent the swap of this. Okay. Take 1 to 2, we get 1 to 2. Step 1, we get 2, 1, 2. Then we get 2 to 1. Back to step 2, if we recover the numbers, back to 1. How do you go back to step 2? Oh, because it was in the recursion area. Then next loop we'll get don't do is a duplicate. Oh, this is only for ignoring swapping the duplicates. And how does that help though? Because if you swap two numbers, when are you pushing back? Okay, so let's write it down, guys. Let's write it down together. See what's happening. What's this list? Okay, anyway. No function call target swapper. Case equal to I swapper. So what's happening is, let's take 1, 2, 3, 3, 4. So first stack swapper is 0 and goes till 1, 2, 3, 4, 5, 4. So if I is not swapper, so for 0, the first item you don't do anything, you move ahead. I is, sorry, so I is 0 and swapper is 0, so are they equal? No. Are they not equal? No. Are they equal? Yes. So we go down and we swap 1, sorry, false, and on the numbers same, true. So stupid. So you swap 1 and 1. So your swapper becomes, so the same I. So I is still 1. So swapper becomes, say, 1. I is then you keep going in, and your first answer becomes 1, 2, 3, 3, 4. Then you come out, and your swapper becomes, goes from 0, 1, 2, 3. From 3 to 4, it becomes 4. Now I goes from 0, 1, 2, 3, 4. 3 to 4. So swapper is now 3. I is 4. So you swap these. So you get 1, 2, 3, 3, 3, 3, 4. Then you come out and your swapper becomes 2. So, and your I is now 3. So you swap 2 and 3. So it becomes 1, 2. If they're not the same, then you swap, otherwise you don't. So you don't swap. Then your I becomes 4. So you swap 2 and 4. So your array becomes 1, 4, 3, 3. Now your swapper goes in as 3. So they're the same, so you don't swap. So you get this is your second result. 1, 2, sorry, fourth result as your third result. You already have 1, 2, 3, 3, 4, which is your initial nums. Then you have 1, 2, 3, 4, 3. Now you have 1, 2, 4, 3, 3. And your swapper comes to 1. So you swap the first and second item, you get 1, 4, 2. Now your swapper starts from 2 and then swaps the 3, 1, 4, 3, 2, 3. Swapper goes ahead, then it swaps 1, 4, 3, 3, 2. You come, if these two are same, then you're not swapping anyway. Then you come out to 1, 4, 1, 2, 4, 3, and then 1 and 2 and 3 are swapped, so it becomes 1, sorry. Instead of 4, this is all 3. This comes after, so it's 1, 3, 2, 3, 4. Then this array is toggled as initially nothing, then so this goes, then 1, 3, 2, last two are toggled, 4, 3, then 1, 3, 2 and 3 are toggled, so 3, 2, 4, then 1, 3, 3, 4, 2, then 1, where did I take care of 1, 2 and 4 getting toggled? 1, 3, 4, 2 3 1 3 4 3 2. Okay, okay. And in the end, when your swapper becomes 0 again and your I becomes 1, then the first element and the second element are swapped. But when you come back, you're passing this nums, this the one with swapped indices, right? Uh, for an iteration, they remain swapped. But for different stacks, they change back. So the first iteration you did 2 1 3 3 4 for this one. Then whatever you do inside is done. Then when you move ahead, it's 2 1 3 3 4. Now 2 1. So because 2 1 3 3 4, now all those starting with 2 are done. Because with for the other loops, we start with the next index and do the swapping for that. So that's why for the next item, your I swapper was 0, next is 3, so you swap 3 and 2. So it becomes 3 1 3, 3 1 2 3. So you make all combinations for that. Hmm. Okay. Hmm. It avoids duplicates because of do not recover them in the code will prevent the swap or 2. But how is that avoiding 1 2 swaps and 1 2 swaps with the other two? It's not, but it's only because it's hmm. Swapper is equal to J minus 1. Okay, so we are getting some duplicates, a lot of them actually. It is because I've probably done something wrong. If I and k is less than target, um, wait, I plus 1? Yeah, I plus 1. Just my swapper. Target and result, yeah. Is something passed by reference? No. Funnily enough, if I think I have done, I just copied it. And I'll just, oh, I didn't sort it. Right. Hmm. So basically, how did we solve just permutation? That was purely This for distinct integers, it's just basic backtracking with no conditions. We've not added any conditions here. This is simple backtracking. Whereas over here, we have added a check because it might contain duplicates, so we don't want the duplicates to be used. Okay. Rotate image. So I've done this using maths entirely, like figuring out what coordinate value becomes what coordinate value, and then just replacing them. Like this becomes some factor, some weird factor of I and j, so on and so forth. But what I had a friend who had this question in an interview, and what he told me was a much simpler one, I think, than calculating the math. That math, I can show you that math somewhere. It's on leetcode. Sorry, IB. Um, hmm. Yeah. So what he told me was that you just iterate from so you keep just one variable, two variables, left and right, which is your left cap and your right, your starting point and your ending point. You start from 0 and you go till n by 2. Was that for even? It's 1 2 3 4 1 2 3 4 1 2 1 2. So you go 4 by 2. So n plus 1 by 2 for even. 2 times. So like 0 to 1. And for odd, you can just go for n by 2, which is also 1 for 3, which is more than enough. And so basically you go from left to right from 1. So basically you replace 1 with 3. I mean, sorry, 3 with 1, 9 with 3, 7 with 9, and 1 with 7. And so you do this 1, 2, 3, 4. So do these 4 calculations and n by 2 times for odd numbers 0, 1. So like for odd numbers n by 2 and for even numbers n plus 1 by 2 times. Times, not index counting wise, not 0, 1, just once or twice. And then you update your left, which is indicator of your left and top, which is your I essentially, and J starting point, and then you go till right for both I and J. So it's just one for loop n by 2 times. So let's int counts equal to uh, counts equal to 0 if mates dot size percent 2 equals 0. So basically if it's even, um, then counts is equal to, let's save this as s because we're going to be using it quite a lot here. then is equal to s plus 1 by 2. Else, if it's odd, then counts is s by 2. So for int I equals 0, I is less than s, I plus plus, sorry, okay, um, okay, I is less than s by 2. So for odd numbers, uh, we go once for 3, so s by 2. Um, sorry, counts, we already calculated that. And for even numbers, we go for 4, we go twice. So size by 2. Actually, it is. I was thinking as in terms of last index. So turns out I'm stupid. Okay. Um, what's next? Um, I have to do four calculation. Sorry, not four calculations. You have to do for int j equals 0. J is, and so now it's not 0. We should keep the lefts and right also. Int left equal to 0 and right equal to s. So I equal to left and it goes till, sorry, no, it's not gonna be count, it's gonna be right only. And j is less than right as well. D j plus plus. So it also starts with left. Now we store so int store equals, let's store this number, which is matrix I j. Now this is going to be replaced with uh, what's right underneath. So let's replace this number. So matrix I j is equal to just swapping those values I think is enough. Matrix j I. Let's see, for 0 0 it says 0 0, so that's not true. For 1, so you have to rotate it right actually. So let's look at it like that. So you have to move it. So you have to move a number. So first one is you move it You move it right minus left steps. Let's draw a bigger example to clearly see the math behind it. So let's draw five sized array. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 2, 23, 24, 25. Okay, so we spin I here to here, 3 over here. Let's see where exactly 3 or 4 is going. So 4 was 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. So 4 was 0, 3, and now it becomes 3, 4. For 7, 7 was 1, 1, and it becomes 1, 3. 8 was 1, 2, and it became 2, 3. So 3 was 0, 2, and it became, sorry, so 0, 0 becomes 0, 4, 0, 1 becomes 1, 4, 0, 2 becomes 1, 2, 4, so on. There is some pattern for sure. 0, 0 becomes 0, 4, 0, 1 becomes 1, 4, 0, 0, 0, 2, 3, 4, 2, 3, 4, 4, 4, 4. So for the outermost one, for the first row, it goes here. 0, 4 becomes 4, 4. 1, 2, 3, 4. 2, 3, 4. 1, 4 becomes 4, 3. 4, 2, 4, 1, 4, 0. I'm guessing, yeah. Then this becomes 4, 4, 4, 3, 4, 2, 4, 1, 4, 0 becomes 4, 4 becomes 4, 1, 4, 0. Sorry. Yeah. What? Yeah, of course. 4, 4 becomes 4, 0. Comes 3, 0, 2, 0, 1, 0, 0, 0. Almost seeing the pattern here. So it's definitely going to depend on int change is right minus left, and now 4, 0, 3, 0, 2, 0, 1, 0, 0, 0 become 0, 0, 0, 1, 0, 2, 0, 3, 0, 4. Okay. So So for each of these, I have to see for inner ones, but I'm making a rough guess. Let's look at the one small example. So 1 1 becomes 1 1 becomes 1 3, but 1 2 becomes 2 3. Right is 3. Okay. Hmm. So we can move this, which was this becomes this, right? So this is going to be right minus j. Or is it going to be size minus j? Let's say size minus j. Size minus j 0. 0 1 2 3, which is our full रो के लिए जो सेम रहता है is I. ठीक है. This row is now moved to the here. This is 40 replaced by this s minus j minus j is replaced by whatever is your this is put here, this is put here, this is put here, this is put here, this is put here. What I'm doing is I stored this, I just put this here, right? I stored this and this. What am I replacing it with? This I'm putting here. I'm gonna store left I बढ़ जाएगा तो sorry. I stored this. I put this. I put this over here. I need to put this over here. which is 4 क्या है? तो राइट लग रहा है मुझे. And something that decreases with minus j. Size minus j. Could be, could be. This is for going in. This is for going for iterating. So yeah, this is fine. Now we have to replace this with that. That also looks like matrix something comma right? J comma right. Is it I? I was, what was I? I was 0, right? It could be if this is I, no? ये जो मैं right लिख रहा हूँ, this might be left. So then matrix, I mean, this might be like, I don't know, count minus I or something. Then you replace j comma right with I comma with whatever you stored. What is this gonna be when this is 1? This is 1 1 1 1 1 2 1 3. It's gonna be replacing 1 3 2 3 3 3. So this is not right. Yeah, this is right. That's correct. But which is also something else. And this is going to be left J. Yeah, man, looks actually looks good. So hmm? Byte which require 4 bytes. Runtime binding to misaligned address. Matrix right is size. Okay. Hmm. Um, for 4, just run it again, although that's not going to change the result. No, sorry. It's fine. Let's debug. 1, 2, 3 was okay. After first loop, the outer section should have been changed. Okay, it breaks in the first loop only. See where it's breaking. What is this change? It's useless. Okay. See after how many loops? After first loop. First loop only it breaks. Awesome. What is S? S is the size. Minus. So it actually has to be. Is it? Left's gonna be updated as well, so I don't think we need. Sorry. Let's just see it once passing. Stop. Run code. Again, my bad for doing this question. It's a sort of an if else style, but this was asked in an interview, so I guess it is sort of important to cover. Cool. 1, 2, 3, 4, 5, 6, 7, 9. And it becomes 947, which what is 947? 947 totally off 852 852 947 852 361. Okay, totally off, guys. Let's debug and see what's happening. So let's see if our variables right in the first try. So we have to change. We store this, and you have to replace it with 7. So let's add these variables to our watch. This is a variable. This is a variable. Okay, this is totally useless. It's not really giving us the values. Okay, so what is S? What is J right now? It's 0. So the end of matrix, which is 4, so M0. So basically, this should become. We have 1, so this should become 7. Which it does. Then, sorry, 7. Now the 7 needs to be replaced by the 9. Then the 9 needs to be replaced by the 3. Then the 3 needs to be replaced by 1. So that's fine. Now we just move to the right. We saved 2. Now 2 needs to be replaced by 4. Replaced by 4. So we go one step above 7. And what is the row? We are still in the 0th row, which is the column. So this becomes 4. 4 become, sorry, 4. 2 becomes 4. 4 becomes 8. And 8 becomes 6. And that's awesome. I'm not able to understand what might have gone wrong. Oh, we don't have to take care of the last number actually, because that uh, got taken care of already. Let's try that again. Awesome. Let's hope it works for even cases too. Awesome. So yeah, I think the 5 size example really helped me to figure these all out pretty easily, because the indexes are not very close, so you can see a clear difference. Okay, group anagrams. Okay, now all inputs will be in lowercase. 8 et net and bat. Hmm. Okay. Hmm. So one option is to sort everything and then sort all the strings inside and then sort our list and then just group all the same ones, but that does make sense. The order of your output doesn't matter. Hmm. So one option is to check, say start with this first number. So let's look at brute force. Since I'm not able to, since I've not done this question before, I'm not able to just think directly what could be a solution. So sometimes you can start with brute force and then actually come up with a solution from that, because you might think that okay, these cases are unnecessary, so we can reduce our runtime somehow. Okay, so you start with the first string. You start check for every string if those two are anagrams. Uh, Maybe just pass it to a function that sorts and equates them. If it is, then so you keep your first item in a list, and then you push the item that you found in that list as well, and also uh, take it out of your input, and you keep doing so. And when you're done, you go to you take the next input string. So worst case, every string, the first string is going to be compared to every string. The second string is going to be compared to every other string except the first one, because it's already out of the list, and so on and so forth. Um, so which is n plus n minus 1 and so on, which is n square. Um, so that's n square plus the time it takes to check to if two strings are anagram. So plus n log n, k log k, where k is the length of the largest string. So n square plus k log k. Okay, so let's try this solution. I cannot seem to find any issue in this solution, so it probably is fine. So we are going to have a return value, and if strs dot size is 0, which is return red. LeetCode's famous for adding these cases. Now we create vector string temp dot push underscore back strs 0 strs dot erase strs dot beginning. Okay. So we have our first item in the temp list, and also we will be keeping the checker as okay. So while okay, so for let's do while true. We also need an iterator. So int I equals 0 for int j equal to 0. J is I don't know what to check. J plus plus.